All right, today we're going to tackle a huge puzzle in the software world, the very strange case of AI coding assistants. There's a paradox here that's got everyone scratching their heads, from brand new developers all the way up to VPs of engineering. So let's just jump right in with a question that honestly might make you a little uncomfortable. We've all bought into this idea that AI makes everything faster, right? But what if for the really important, complex stuff, the opposite is actually true? And this, right here, is the heart of the paradox. A major study uncovered this massive gap between how developers feel and what's actually happening. Experienced developers felt like they were crushing it, working maybe 20% faster with AI. But the hard data? It showed they were actually 19% slower. So what in the world is going on here? Okay, to really get this, we've got to look at the big picture right now. It's basically a tug of war between two massive opposing forces. On one side, everybody's using AI, and on the other, nobody really trusts it. I mean, on one side, AI tools are everywhere. A staggering 84% of developers are using them in their day-to-day work. They're not just some neat little gadget anymore. For most people, they're a fundamental part of the toolkit. But, and this is a big but, look at the other side. Trust has totally fallen off a cliff. Even though almost everyone is using these tools, only 29% of developers actually trust the code that comes out of them. Think about that. We're all using a tool that deep down we don't really believe in. That's a huge disconnect. All right, so let's start with the positive side of the story, the argument for speed. Because when you look at the industry from a bird's eye view, the data tells a pretty compelling story that AI is a massive win. So you've got this data from Jellyfish, right? They looked at tons and tons of projects and found that teams who are all in on AI, well, their pull request cycle times, that's basically how long it takes to get code from a developer's brain into the final product, dropped by a huge 24%. I mean, on paper, that looks like a slam dunk for productivity. But then a proper scientific study dropped, and it told a completely different story. A pretty shocking one, actually. And this is where that shiny illusion of pure speed really starts to fall apart. Yeah, the result from the METR study was a real jaw-dropper. They ran a randomized controlled trial and found that when you give senior developers really tricky, complex problems to solve, the ones using AI were 19% slower. Not faster, slower. And look, this wasn't just some quick online poll. This was a super rigorous study. They used highly experienced pros, put them on massive, million-line code bases, and gave them actual bugs and features to work on. This is about as close to real-world engineering as you can possibly get in a controlled environment. So, this is the big question, isn't it? How can we have a 24% speed up and a 19% slowdown at the exact same time? How can both of these numbers be true? It feels impossible, but they are. Well, the answer is hidden in all the stuff we don't usually measure. The invisible work, the little frictions that AI introduces that add up to a huge drag on your productivity, especially when the work gets really challenging. The researchers who ran that study pinpointed these 5 key friction factors. Things like the mental cost of switching your brain from deep coding to prompting, the extra burden of reviewing code that looks plausible but is dangerously wrong, and just navigating the sheer complexity of a real system that an AI can't possibly understand. The developer's job changes from being a creator to being, well, a detective. Let me give you a perfect example of this. It's called the almost right trap. An AI spits out this piece of code for a bank withdrawal. It checks if you have enough money, and if you do, it subtracts the amount. Seems totally logical. What could go wrong? But it's a trap. In a real system where thousands of things are happening at once, this code is a disaster waiting to happen. It's a classic severe bug called a race condition. 2 withdrawal requests could get in at the exact same time, both see the balance is okay, and then both subtract the money. Bam, double withdrawal. The AI has no idea about this kind of context, and fixing that bug down the line could take hours, if not days. Okay, so here's how we solve the paradox. AI is amazing for the easy stuff. Writing boilerplate, looking up simple syntax, helping a junior developer get their bearings. It absolutely crushes those repetitive, low-complexity tasks. And that's what that 24% speed up from the Jellyfish data is capturing. It's measuring a ton of that easy work. But for the really hard stuff, the kind of work that senior engineers get paid to do, things like core business logic, deep-level debugging, security, for that work, the AI actually creates more work. It adds this massive tax of having to double and triple check everything. And that is the slowdown that the METR study found. This whole thing points to an even bigger problem, which is how we're even measuring productivity in the first place. Because if you start tracking the wrong things, you can actually make this entire problem so much worse. It's a perfect example of something called Goodhart's law, which basically says that when a measure becomes a target, it stops being a good measure. So if a manager starts judging their team on lines of AI-generated code, what's going to happen? Developers are just going to generate a mountain of useless code to make the number go up. The metric becomes actively harmful.
So what's the solution here? The answer is definitely not to just throw out all the AI tools. No way. The key is to be smart about it. You've got to be strategic. You need to know when to step on the gas and when to slam on the brakes.
The best strategy we've seen for this is called a bimodal approach. It's actually pretty simple. You split your work into 2 zones. You have a green zone for all the low-risk stuff, boilerplate, unit tests, documentation. Go wild with automation there. But then you create a red zone for the critical high-stakes work, your core business logic, security, architectural decisions. And in that zone, human oversight isn't just a suggestion, it's a hard requirement.
When you really step back and look at it, this reveals a brand new concept, the thinking decelerator. We thought we were buying a tool to help us type faster. But here's the thing. Software engineering isn't a typing problem, it's a thinking problem. And when you apply a typing accelerator to a thinking problem, you can, paradoxically, slow down the most important part of the job, the actual thinking. And that leaves us with one final big idea to chew on. The most valuable engineering skill in the very near future isn't going to be writing code, it's going to be reviewing it. The entire game is shifting from pure creation to critical analysis and verification. So the question you have to ask yourself and your team is, are you ready for that shift?